Hey, it's me, Destin. Welcome back to Smarter Every Day. We are right in the middle of a deep dive here on Smarter Every Day into nuclear submarines. We're investigating all these different things about how nuclear submarines work, and we're trying to learn very detailed information about each individual thing. Today, we're going to talk about torpedoes, which is fascinating to me because I've actually been downrange from a torpedo when it's engaged a target. This is me in a helicopter back in 2018 as the part of my job, which was a developmental weapons tester. I'm filming the USS Racine waiting on a Mark 48 torpedo to impact, and when it did, it was devastating. That was a part of RIMPAC, the Rim of the Pacific exercise. That activity took place at what's called the Barking Sands Missile Range Facility. And what's so interesting about that is they test missiles there, but they also test torpedoes. If you looked off the coast of Kauai at any given day, you could see a helicopter towing a torpedo that it had picked up out in the ocean after being fired, and they did some kind of weapons development. But here's the deal. Even though torpedoes are super fascinating and they're modern and they're constantly being changed, they are a very old technology. In fact, they were used to great effect during World War I, so this technology needed to fire a torpedo from a submarine is very old, but generally speaking, most people don't know how it works. Today, we're literally going to crawl inside the torpedo tube of a US nuclear submarine in the Arctic Ocean under the ice, and we're going to be able to look around inside this tube and try to understand how all these things work. All right, let's do it. Let's go get smarter every day.
So heading down towards the torpedo room.
Torpedo room. That's what I'm talking about.
Oh yeah.
This is the party.
And so what whiskies you get half flooding. This is one of the very few, right?
Oh well, I'll be dang. There we go.
And there it is.
And there it is. Okay.
So what we got here is
Gonna touch it.
So my name is Alan Howell. I'm the Torpedo Division Chief Petty Officer here on the USS Toledo.
Oh, awesome. Rock and roll. So you're over the torpedoes. Did I understand correctly?
Yes, sir. That is correct.
Okay. So right now, where are the torpedo tubes?
So torpedo tubes are for the ship on the port and starboard side. So we currently have 4 torpedo tubes on the 688 class submarine. 2 over here on the starboard side, 2 over on the port.
So that's what I'm seeing right there?
Yes, sir.
Okay.
So what you're seeing is the breech doors.
And there's one way over there.
And there's 2 more over on that side.
2 on that side. Okay,
Yes,
got it.
So what you're seeing is the breech doors, and when we're done with this evolution, we can open them up for you. And if you want to crawl down in there, you're more than welcome to.
In the torpedo tube?
Absolutely.
Crap yeah, dude.
Yeah,
Let's
good.
do that.
We send our torpedo men down there once a month for maintenance, so we dive the tubes every month. So we're in there all the time.
I like you already.
So you're in.
Rock and roll. I'm going to set this camera up over here. So, well, no, I guess it's going to open that way, isn't it? Can I prop it on this?
We got a greenie if you want to put that on. It's probably going to be wet down there.
So this is
TM2 night.
TM2 night. What does TM2 mean?
It means torpedoman's mate.
Torpedoman's mate.
Yes, sir.
Okay, cool. And my understanding is this is a torpedo tube,
Yes, sir.
and there's a thing that you're going to let me do.
Yes, sir. So we're gonna open up the breech door and let you crawl down inside and sign your name or at least try to sign your name on the muzzle door.
This is the standard door for a torpedo tube, I guess.
Yes, sir.
And it's hydraulically operated, you said?
Yes, sir.
Okay, and this is a torpedo, right?
Yes, sir. Mark 48 ADCAP
What's ADCAP mean?
means advanced capability.
And so this yellow stripe right here means that is a live torpedo.
Yes, sir.
That's amazing.
If you think about what's going on here, you've got this long torpedo down in the bottom floor of this submarine. How did it get there? Because we barely have enough room to move around.
Okay, so this is Jacob, the assistant weapons officer.
I'm also the diving officer, so I'm responsible for biggest responsibility is probably rig for dive, which we'll talk about here. But this is the command passageway, naval tradition kind of thing. It's an area where you're supposed to minimize passage. Only certain people are allowed regular passage through here. Right here is the weapon shipping hatch. It happens to be the most convenient way to get into the ship, but it's also the primary means by which we load torpedoes, actually.
Really?
Right now it's rigged for dive, so I can't just open this without captain's permission. But if you were to open this, it swings down that way. You see that hand wheel or that lever right there.
Right.
Turn it and it will swing down that way. You'll see that it's actually at a cant, and that's so that torpedoes actually come in like this, and you wonder where they're going to go. Well, these plates right here, these deck plates, you take them out, and there's a tray underneath that actually swings downward. It's hinged on this side.
Coming through, Captain.
And likewise on the next deck down, take the deck plates out, shipping tray hinges downward, goes all the way down to the torpedo room, and we load torpedoes that way.
What I think is fascinating about this is the geometry of taking this huge torpedo and getting it to the bottom floor. All this was figured out way back in the day. Like, the first Los Angeles class submarines were laid down in the 70s, which means all the decisions those engineers made back then affect what types of weapons can be fired now. Now, I couldn't find any footage of loading torpedoes into a Los Angeles class submarine. However, I did find footage of a Harpoon missile being loaded. Now, that has the same geometric form factor as a Mark 48 torpedo, but what's interesting is if you watch how they do this, it's like a choreographed dance to get this torpedo down to the bottom floor. So it doesn't matter what technological advancements you make in the weaponry itself, or the seeker heads, or the guidance, or the fire control. It doesn't matter. You are still constrained by the physical size of the torpedo tube and how you can physically lower it down to the bottom deck of the boat. When it comes to actually inserting the torpedo into the tube, there's either one of two ways that it's done. Number one, you can use hydraulics, which basically pushes the round all the way into the tube, or number two, they can actually override that and do it with snatch blocks and muscle power, because snatch blocks are awesome.
What do you call this contraption here? This is the door of the torpedo?
That's the breech ring, or breech door for the torpedo tube.
Okay, and so if I understand correctly, you're going to open that, and what you would normally do is you would go inside and you would clean it. Is that right?
Yes, sir.
Okay, and you're going to let me try?
Yes, sir.
So how do you open this?
Alright, so first we're going to verify that everybody's clear of it, and that there's nothing interfering with it, because it's hydraulics. One, clear. Alright, and then just pull this plug.
Wow.
Make sure it's latched. And there's the torpedo tube.
Oh, that's awesome. Okay, I'm gonna level with you. This was the moment in my life where I realized I was being offered a chance to crawl inside a torpedo tube in a nuclear submarine. So, side note, how the heck did that happen? But when it comes right down to the reality of what's about to go down, how does a torpedo fire? I did not know how a torpedo leaves the tube of a submarine. No clue. Before we crawl down in the tube, I want to try to explain how this thing works so you'll have a better idea of what we're looking at. This is a model of a Mark 48 torpedo. Just 3D printed this, painted the whole bit. I'm really proud of it. Anyway, there's something really cool about this I want you to see. If you look really close here, on the top of this thing, you can see there's this little tab kind of thing, right? So those little tabs right there have a very specific purpose. If we open the back of the torpedo tube, you can see that on top, there's this little Y, and that Y guides that little tab into the tube so the torpedo will always align to the correct orientation. Up will always be up. But there's other things you can do, right? Not only does it give you radial alignment, but it can give you axial alignment along the longitude of the tube. I don't know if I'm saying that right, but I think you get it. So as it goes in, if you have something that's pushing down inside that little Y slot, as the torpedo goes forward, boop, it'll bump right there, and it'll stop the torpedo from going any farther. If you have something on the back of it, that'll keep it from going backwards. So at that point, you have constrained the torpedo in 6 degrees of freedom. Roll, pitch, yaw, X, Y, Z. Just with that little slot and 2 little lugs on each side. Before we go down the tube, I want you to understand exactly how the torpedo launching system works. So the first thing we do is make sure the locking lugs are in the correct configuration, and that's that little tab thing I was explaining would keep the torpedo from sliding forward and backwards. So the forward locking lug is going to be in the load position, which means it's going to be down, but the back one is going to be up. Next, we open the breech door and we can slide the torpedo in. Again, we can do that with hydraulics or, my favorite way, snatch blocks. Once the torpedo is in and the locking bolt on the torpedo has moved up against the locking lug in the tube, the aft locking lug comes down and secures the torpedo in the tube in case the submarine pitches up for some reason. You don't want it to slide against the breech door. At this point, the breech door is shut and locked, and now the torpedo is stable inside the torpedo tube and ready for use. In the event they actually want to fire the torpedo, the following sequence takes place. First of all, you have to flood the tube. There's a tank full of water called the WRT, or water round torpedo tank. A valve is open to allow water to flood the tank, but because there's air in there that you have to let escape, you also have to open a valve up top that will vent the air out as you fill it up with water. So this venting of the air back into the submarine is critical because air is a precious resource. You're a submarine, you're a set volume. Now, it's cool to move air around in different compartments in the submarine, but you never let it go because you only have the air that you brought with you, especially when you're under the ice, and you don't want to have to come back to the top, or in this case, you can't go back to the top and get more. So, It's important to preserve your air. Okay, so the water from the WRT tank is filling up the torpedo tube itself, and at some point it completely fills the tube and starts to go up into the vent line. Up there's an electrode that senses the seawater, and at that point, the valve on top and the valve on the bottom close at the same time, and we have a torpedo tube completely filled with water. When you go to fill up the torpedo tube with water, you can't take water from off the boat, because if you have hundreds of gallons of water that you need to fill that tank, suddenly that's like putting thousands of pounds on the front right corner of your boat, which would cause you to tip like this. So in order to do this, they have this carefully choreographed buoyancy ballet where they take water that's already on the ship. In fact, it's very near the tube, and they fill the tube with that. So there's no mass exchange between off the boat and inside. That way, they can carefully trim everything out, and it will stay trimmed throughout the entire firing sequence. So at this point, we have a torpedo tube that's filled with water, but the problem is it is at a lower pressure than outside the boat, because as you know, the deeper a submarine goes, the higher and higher the pressures can get. So what we have to do is equalize the system, and that's the purpose of this valve right here, the equalizing valve. Once we turn this thing, the pressure in the tube will now be the same as the pressure out in the ocean. Now that we have the same pressure on the inside of the tube as we do on the outside of the submarine, we can open the muzzle door because the forces are equalized, but it's also time to move what's called the slide valve. The slide valve is a movable part of the tube that's about midway down the torpedo that concentrically covers all these different rectangular ports through which water can travel. So the slide valve moves, exposing those rectangular ports, and now you can dump water into the torpedo tube. At this point, we are completely ready to fire, and when the fire command comes from fire control back in the control room, both the locking lugs retract, which frees up the torpedo to move axially, and pressurized water from an impulse tank provides a tremendous amount of pressure and flow, which is then introduced into the torpedo tube from all those rectangular holes which were covered by the slide valve, and this additional water in the tube pushes the torpedo out the front of the submarine. Okay, what I'm about to tell you, I do not know for a fact, but think about it. We had a huge torpedo in the tube, and we fired it, and it is no longer on the submarine. The weight of that torpedo is gone, which tells me that in order to maintain balance in the system, an ideal torpedo is probably neutrally buoyant. Anyway, so at this point, we have to return the system to its original state without gaining or losing mass. How do we do that? Okay, so the first thing we're gonna do is we're gonna close the muzzle door and close the slide valve and then close the equalizing valve. At this point, the tube is now shut off from the ocean. And this is the other magic trick. How do we get all this water out of the tube without changing the weight of the boat? We open this three-way valve down here at the bottom and we divert the water from the tube to the auxiliary tank. But because it's gonna take forever for that to drain and you have to backfill that water with air, we might as well use pressurized air. So we open this blow valve up top and we have a pressurized source of air to force all that water out down into that aux tank. At this point, when the tube is dry, we close both of those valves and we are left with a pressurized torpedo tube. That's unacceptable because we don't want to waste air. So what we do at this point is we open the three-way valve on top and we vent that pressurized air back into the people part of the submarine, and there you have it. All you have to do is unlock and open the breech and lower the front locking lug, and you're ready to load another torpedo in the tube.
That plate right there that you can see, that's the slide valve there. That's where once the tube is flooded down, we would open that slide valve and there's flow slots inside. So that tank is basically just a free flooded area. So on the other side of that valve is water.
Where is the valve?
It's this giant plate right here that would slide forward and uncover the flow slots.
Got it. Got it. So this thing moves forward and there's holes around the outside that pushes the torpedo out.
Yes, sir. The torpedo gets loaded in all the way down. We flood down the tube. We equalize it with the sea pressure, and then that slide valve, once we open the muzzle door, will open, and that pressure pushes the weapon out of the tube.
Got it. Okay. Cool. So just crawl down there and sign my name at the end, right?
Yes, sir.
Am I still rolling?
You're still rolling.
So what can I not step on here?
You don't want to step on.
Can I step on the nose of the torpedo?
I would step right here.
Okay, thank you.
There's sensitive stuff in there.
Okay, here we go.
Put your foot on here.
Thank you. Oh.
Yeah, you couldn't be claustrophobic and do this, could you?
No, sir.
So these valves here are these little screens?
Those are just strainers to make sure that whenever we drain the torpedo tube, nothing solid gets into the system.
Gotcha. So there's seawater on the other side of this?
Yes, sir.
That's crazy. So sign my name right here?
Yes, sir. Anywhere you like.
Oh, a lot of people have done this. Huh. It's really, really cold. I guess because we're in the Arctic, huh?
Might have something to do with it.
There's no way this marker's gonna work. It's literally ice. Well, there was an attempt.
So that's all you can ask for.
That's all you can ask for. Let's see if I can see you. That's awesome. You're a really long ways away.
About 20 feet.
20 feet?
Yes, sir.
It's pretty cool. Sweet. Coming back.
All right. There's ice on it. Yeah.
So is that a detent slot?
Second. Oh yeah. So what you're looking at right now is the stop bolt.
Yeah.
So when we load the torpedo in, it's got a little notch on the top of it. So we load that in, and that forward one, it is down. So that tells it. So that stops it, and then we roll it so that the rear one comes down as well, and that locks the torpedo in place so that it's not going to come out of the tube with the breech door open. And
Oh, I see. So it's a cam that rolls.
yes, sir.
Did you grease it?
We have greased it.
That's awesome. It looks like it's riding on some type of Teflon or Delrin or something.
Yes, sir. That's the sliding surfaces so that the torpedo has something to slide on without scratching or damaging it.
That was awesome. That was really cool. It was ice.
Yeah.
Is that normal? That's just the Arctic, I guess.
Just being in the Arctic with how cold it is.
That's amazing. Well, that's something I never thought I would do. There was an attempt. All right, so that's sliding down a torpedo tube on the USS Toledo. Thank you.
No problem, sir.
Appreciate it. It was freaking cold, is what it was. Like ice.
Like real cold, I know.
Ice at the end. Yeah, I didn't expect that.
This video is a part of the Smarter Everyday deep dive series into nuclear submarines. We're going to study a whole bunch of different stuff, and I would love it if you would consider subscribing to learn about this stuff with us. It's fascinating. There's way more to come. This episode is sponsored by Raycon. If you've never used Raycons, highly recommend it. These are called the Everyday E25s, and I want to show these things to you. Check these out. So this black pair here was given to me when Raycon was like, hey, are you interested in letting us be a sponsor of Smarter Every Day? Check them out. I absolutely love them. These things are like half the price of other premium earbud audio brands, but they sound just as good. They're very comfortable. When you buy these things, they have all different kinds of little rubber things that go in your ear. You can get the exact size that fits you the best. They're fantastic. You get 6 hours of playtime per charge, and you're gonna dig them. I highly recommend these. I use them when I bush hog this field, as a matter of fact. It's about time to do that again. If you wanna try these, go to buyraycon.com/smarter. You get 15% off your order. I recommend the Everyday E25s. You're gonna dig them. You can pick whatever color you want. I like the blue ones myself, but you know, whatever you like. Big thanks to Raycon. I like your products. In the last episode, I showed a little orange flower and said Dad and I don't cut it because the butterflies like it. Turns out it's called butterfly milkweed. People told me that in the comments. There it is. Told you the butterflies like this stuff, and they're pretty. Thanks for making me smarter every day in the comments. I'm Destin. I hope you stay tuned for the rest of the Smarter Everyday deep dive into submarines. We're gonna learn a lot of stuff. How do you make pizza on a submarine? What are the bathrooms like on a submarine? All kinds of stuff like that. Please consider subscribing. There's a lot more to learn. I'm Destin. You're getting smarter every day. Have a good one. Bye.